All right, if you were in my calculus class, I'm sorry, this is 1.3 limit rules. And if you are in my pre-calc class when we start learning calculus at the end of the year, this is 1.2 from what we do there. This should be a fairly easy lesson for you guys. This one is called limit rules. And this is just generically how to solve any limit when it's given to you through an equation. Okay? So the first one is that the limit of a constant is always going to just equal that constant. So if I tell you the limit as x approaches 4 of 7, the answer is just going to be that constant. And hopefully that makes sense to you because the function 7 is just a horizontal line at 7. And no matter what x value I look at, the y value will always just be 7. Okay? So next is the limit of a function. And that's found by simply plugging in the x. Okay? Whatever you get out is your answer. Okay, so take a look here. If I say the limit as x approaches 3 for this function, x squared plus 1, I plug in the 3, and I get out 10. If for whatever reason you do not get out a clean number, which does happen at times, that's when you want to clean the function algebraically and then plug it back into your leftovers like we've seen in the previous videos. Okay, so let's check out some of these examples. So for question number 1, the limit as x approaches 2 of 3. This is the limit of a constant, and it is just that constant 3. Okay. The limit as x approaches negative 4 of x, all I have to do is plug that number into the function. So my answer is just negative 4. Okay. The limit as x approaches 2 of x squared, I'm just plugging in that 2. So I'm saying 2 squared, which gives me 4. All right. Easy enough? Let's keep going. The limit as x approaches 2 of this function, I'm going to plug that 2 in. So I would say 4 times 2 squared plus 3. And here I just tell you to make sure you're being careful with PEMDAS. 2 squared is 4. 4 times 4 is 16. And then plus 3 is 19. Okay. If I have more than one x, you have two options. I can distribute this x squared and clean the function, or I can distribute the 1 just to every time I see an x. So it would be 2 times 1 being multiplied into 1 plus 4. Again, make sure you follow PEMDAS. This is 2 times 1 plus 4 is 5. So this should give me 10. Okay. So again, no matter how many x's I see, that is what I'm plugging my limit into. Okay. So I have, let's see if I fit it here, 1 squared plus 1 plus 2 over 1 plus 1. So you should end up getting 4 over 2, which equals 2. Now I know in the past videos you were kind of used to fractions not working out, but that's only if the denominator gives you 0. So for example, you might think to yourself, what number would I be doing the limit of that would give me an issue? Well, what would make this denominator equal to 0? And that would be if x is negative 1. So the limit as x approaches negative 1 for this problem would be the only time that you'd have an issue that you'd have to clean algebraically. But we'll see some of those soon. All right, now you plug in your 3. And now I have cube root of 2 times 3 squared minus 10. Just make sure to follow PEMDAS. 3 squared is 9. 9 times 2 is 18. 18 minus 10 is 8. So I'm really working with the cube root of 8, which is 2. Okay. For a piecewise function, okay, it is always very important to remember that a limit only exists if it gives you the same exact number from the left and from the right. If I were to do the limit of 3, then I can safely just plug it into this one because I know 3 is an x value that is greater than 2. And I would only have to plug it into this one function, okay? But because I'm plugging in a limit at a point where the piecewise function splits, I'm going to have to check both the left and the right side to make sure that they both give me the same number. So I'm going to plug one in here and one in here. The left side is going to say 3 times 2 plus 1, which gives me 7. And then here on the right side, which is the bottom equation, I have 2 times 2 times 2 minus 1. Okay? So this gives me 4 times 1, which is 4. The fact that 7 and 4 are not the same number, that means the limit from the left and the right do not agree. So this is a does not exist scenario. Okay? And now let's look at this last one. If I plug in a negative 3, I have a negative 3 squared plus a negative 3. Whoops, should not have put parentheses there. Minus 6 over negative 3 plus 3. Now, the fact that I can already catch that my denominator is going to give me 0 is my little red flag to let me know that this is going to be a problem. I'm going to have to factor to be able to finish this. So, always keep an eye out that way you're factoring in one of the sides of the fraction. It's probably going to be a match with what's left over on the other side of that fraction. So I'm going to change this to 2 binomials. This is my numerator that I'm working on. X times x gives me x squared. 2 times 3 gives me 6. And if I want to have a positive one, then I need a positive 3 and a negative 2. All of this over x plus 3. Okay, this is what I'm doing the limit of now. Now, if these two cancel out, the only thing I'm plugging that negative 3 into is this x minus 2. Okay, so I can say negative 3 minus 2 gives me a negative 5. Okay. All right, for this next question, I'm going to show you a method of algebra, of cleaning using algebra that is a little more complicated. I'm going to expose you to it. I don't want you to panic about it because the good news is that once we learn derivatives, we're going to learn this shortcut called L'Hopital's, and we won't end up having to use this lengthy algebra method, okay? But for now, until we learn it, I am going to expose you to it. So if I go to plug in 0 here, without even looking at the numerator, I see that I'm going to get a 0 in the denominator, okay? If I did plug the 0 up here, I'm going to get 0 plus 1, square root of 1, which is just 1, and 1 minus 1 is 0. We had said that this is called an indeterminate. Okay? So now one method that I can do to fix this is to multiply this function by the conjugate. So what a conjugate we had spoken of is that whenever I have a squared minus a squared, I can have the first term minus a second times the first term plus the second. So if I think of what piece of the conjugate I have here, I have a first term minus a second. So if I say that this is going to be the one that holds the first term minus the second term, then I'm going to multiply this top and bottom by the first term plus the second term. Okay? And then whatever I do to the top, I'm going to do to the bottom so that I'm not changing the value of this function. I'm technically just multiplying it by 1. Okay? Now, if you remember the rules I went over about conjugates, when I have the first minus the second times the first plus the second, I can just say the first squared, which is square root of x plus 1 squared minus the second one squared. And then at this moment, I'm not going to clean the bottom. I'm just going to leave it messy because this is going to end up cleaning up real nice. So here, this squared will cancel out with its square roots. And 1 squared is just 1. So in my numerator here, I'm going to have x plus 1, and then this minus, and 1 squared is just 1. All with this same denominator, which will end up cleaning again to just x over x times square root of x plus 1. And one more time, we see that these x's cancel. So what I'm really working with is the limit as x approaches 0 of my remainder here, what I'm left with, which this is in the denominator, so I have to put a 1 in the numerator, over square root of x plus 1, and all that plus 1. So now when I plug in my limit, I can say this is 1 over square root of 0 plus 1, which gives me 1 over 1 plus 1, which gives me 1/2. So again, a little lengthy, but the algebra does make it clean up nice. But in the future, once you learn derivatives, which is coming up in chapter 2, you'll learn a method called L'Hopital's, which lets you do this much quicker. All right, so the two last things we're going to look at today, one we've already talked about, average rate of change, which we said before that is just slope, which is y2 minus y1, the change in y's, over x2 minus x1, the change in x's. So I drew you this diagram to show you where we come up with this one. We've talked about it before. If we call the first x a and the second x b, then there's your b minus a for the difference in the x's. And then if we call this y the function at a and this one the function at b, then here's your difference in y's. So let me show you where the difference quotient comes from, okay? I'm going to do this one in red. Let's say this right here is my first x. And then as I travel this distance in between the x's, we'll call it h. So that means point B would be called this x plus the h, okay? That would make this first y be f of x. And if this x is called x plus h, then this one would be called f of x plus h, okay? So in saying that, we can change our f of b, let's use this formula, f of b to say f of x plus h minus my second y, which instead of f of a, I'm just saying f of x. And then over, instead of b minus a, I can say x plus h minus my a, which is just x. And in this case, you can see that this x and this x will end up canceling out. And then we just have f of x plus h minus f of x over h, okay? So it's a new fancy way of saying slope. I know what you're thinking. Why in the world do they keep inventing new ways of saying slope? But once we start learning derivatives, we're going to start learning all these shortcut rules, which are really nice. But the reasoning behind them happens to be through this formula. And if you can just understand the concept of this formula, you're going to be able to shortcut a lot. So let's look at two questions based on this. All right, so this question says, find the average rate of change of the function f of x, which is x squared plus 3x, from 2 to x when x is not 2. So this is like my a, and this is like my b, okay? And they say that to make sure x, to assume that x is not going to be 2, because if not, that's going to end up being a 0 in my denominator. So the average rate of change, we already said, is the formula f of b minus f of a over b minus a. So f of b means plugging x into the function. If I plug x into the function, I just have x squared plus 3x, okay? Minus f of a means me plugging 2 into the function, which means 2 squared plus 3 times 2. And this is all over b, which is x, minus a, which is 2. Okay? So this cleans up to x squared plus 3x. And this right here cleans up to be a negative 10. Okay? Now, always take a moment and double check to see if you can clean this. This function will represent the average rate of change. But I do see that this trinomial has a binomial that matches with a denominator. And the reason I catch that is because I would want two numbers that multiply to give me 10. And I know that I easily have 2 times 5. So I'd want to check that. So two numbers that multiply to give me a negative 10, but combine to give me a 3. So I have 2 times 5, which is nice because 2 times 5 does give me 10. Now, can I combine that to give me a positive 3? Well, if I put a positive 5 and a negative 2, then negative 2 times positive 5 gives me negative 10, and a positive 5 minus 2 gives me a 3. What's really nice about that is that I can clean this and give myself a simpler function. Okay? So the next part of this question says to find the limit as x approaches 2 of the average rate of change. So all you're doing now is setting up the limit as x approaches 2. The first initial answer that I had gotten is right here. But thank God I kept cleaning, because if I would have used this, I'm going to go through the motions and show you. I would have gone that when I plugged in 2 squared is 4, plus 3 times 2, which is 6. That gives me 10. Minus 10 is 0. Over 2 minus 2 is 0. So that would have led me to my cleaning anyways. Okay? Which I'm not going to redo. It's right up above if you need to see it. And the leftovers is just an x plus 5. So when I plug my 2 into here, I do get a nice clean number. And the limit as x approaches 2 of this average rate of change of this original problem is just 7. All right, last question for today. Find the difference quotient of f of x, which is 2x squared minus 3x plus 1. Then find the limit as h approaches 0. So I'm going to warn you, this is a little lengthy, but it is very easy as long as you're careful with your signs. So step 1 is going to be to plug in an x plus h into my function. Okay? That's going to be part 1. So if this is my function here, I have an x twice, which means I'm going to plug in x plus h twice. I'm going to say 2 times x plus h squared minus 3 times x plus h, and then I have the plus 1. Okay? So if you can follow my little color coding here, this is step 1. Step 2 is going to be to say minus the original function f of x, which is nice. It's already given to me. The big thing you have to remember is to give parentheses, because you're subtracting, that negative is going to end up distributing. And you'll see as that happens now. Okay? So there's step 2. Okay? Hope my brackets make sense there to you in red. And then you need to put all of this over h. Okay? Now, all you have to do is clean. So PEMDAS says I have to FOIL that first. We went over that last class. If you feel the need to write the two binomials and distribute, go ahead. But we had said that that is the first term squared plus double both of them multiplied plus the second term squared. Okay? Distribute that 3. I'm going to write the plus 1, and then I'm distributing this minus. Oops. So now this, the only thing I have left to do in the numerator is to distribute that 2, but let me go one step at a time. All of this is still over h. I'm just going to distribute that 2 now. So I have 2x squared plus 4xh plus 2h squared. And then just rewrite the rest. Now this next part should clean out really nice, and a good rule of thumb is to remember that the original function will always clean out. So for example, if my original function had a 2x squared, there should be a positive 2x squared and a negative 2x squared to cancel out. If there's a negative 3x in the original, there should be a negative 3x and a positive 3x to clean out. And if there's a positive 1, you should have a positive 1 and a negative 1 to clean out. Okay? So let's keep going. I have 4xh plus 2h squared minus 3h over h. And now the really nice thing about this part is that you can catch that every single term has at least one h, which means I could take 1 out of each. This now becomes 4x plus, there's 2 h's here, so I can only take 1 out, 2h, and then minus 3. I took 1 h out of each term. Okay? So as of now, this is the answer to my difference quotient. Okay? Part 2 of this question said to then find the limit as h approaches 0. So now the last part is the limit as h approaches 0 of 4x plus 2h minus 3 means that I'm only plugging the 0 anywhere there's an h. Notice this is not an x, so I cannot plug it there. Oh, I just noticed you can't see what I'm writing. All right, so I'm doing the limit as h approaches 0 of this function, okay, according to part 2 of this question. And like I said, you can only plug 0 into an h because that's the letter that's here. If there was an h, if there was an x here, I could only plug it here. So this is going to give me 4x plus 2 times 0 minus 3. This part cancels out. And so I am left with 4x minus 3 as my final answer for the second part of this question.